Okay, so we have two functions here. We have f of x equals x squared, and we have g of x equals 5x plus 2, right? So let's go ahead and find both those functions, both compositions, f of g of x and g of f of x. We'll show that they're not the same, okay? So f circle g, well, that's just f of g of x. And now, have you guys ever heard of please excuse my dear Aunt Sally? Order of operations? First thing is parentheses, right? So you work inside the parentheses outward. So let's go inside of f's parentheses and look at g of x. G of x we already have an expression for. It's 5x plus 2, right? So now that's what's going into f, and that looks a little more palatable, right? The fewer parentheses. Remember, f says whatever you give me, I'm going to square it, right? So I take that input, all of it, and I square the entire expression. So I could FOIL that out, and I would get a polynomial with 3 terms, right? I'm just going to leave it like that, but that's my f of g of x, okay? So now we're going to do g of f of x. And remember that f is x squared. And g says, whatever you give me, I'm going to multiply it by 5. So let's take that x squared times 5. And then let's add 2. And you can tell that's not the same expression, right? The other one, the whole thing was squared. If we FOILed it, we'd have a middle term. There's only 2 terms here, right? They look a lot alike, but they're not the same function. However, let me just go ahead and talk real quick about inverses. There's another definition of inverses that we didn't use yesterday. And the idea is that we talked about identities with reciprocals. They multiply to 1. X, the function y equals x, is kind of the identity when you do composition. Because you think about f of x is x, and you can think of h of x being anything else. If I compose like this, f of x is just x. I didn't do anything, right? H of x, or excuse me, f of x is just x, so I changed it back to x. That didn't change anything. And if I take f of h of x, well, that means I put h of x in for x, but f doesn't do anything to the function. So that's why we call that function the identity function. Because when you do this operation, when you do composition, nothing happens, right? It's very boring. It's like your little sibling when you're younger would just copy whatever you said. That's all it does. You put an x, he just spits y back. So if that's the identity, what inverses do is when you compose them like this, they compose to x, which basically means that they undo each other, right? So if you compose them, it's like nothing had happened at all. And it's going to happen both ways. And I'm going to give you an example of that using the first thing we did yesterday with those 2 lines. All right? So those functions we had were f of x, x plus 4, and g of x was x minus 4, right? And I'm going to show when you compose these both ways, they basically undo each other, right? So if you take f of g of x, that's f of x minus 4. F says, take that, x minus 4, and then add 4 to it. So those 4's go away and you just get x, right? So it's like nothing happened, right? I added 4, but then I subtracted 4. You can think of composition as like an assembly line. You do the first thing, which is subtract 4. Then I do the second thing, which is add 4, right? You guys ever play those games when you're a kid? My uncle used to do this trick where he would be like, pick a number. Then add 2, then subtract 3, then divide it. He would always get my answer because he was just doing an algebra trick where he eliminated my guess. But the things he was telling me to do, that's composition. You do the one thing, and then you do the next, and so on. Now, if I go the other way, let me double check myself. F says to add 4, and then G says take that and subtract 4. So you're going to get x plus 0, which is just x. So those undo each other. They're inverses. When you're done, you didn't do anything to the value of x, right? You just put it back out. Does that make sense? Now, the last thing I want to mention is part 3 and 4 of part B. So let me write that, B3. There's two ways to think about this. Here they want f of g of 2. And what I'm going to do here is I already found f of g of x a few slides ago, right? What was that? F of g of x was 5x plus 2 all squared. So let's just put x in, right? If I've already got the function, I just put x in for x is 2, right? So that means x is 2, and I get 10 plus 2 all squared. So I get 144, right? So that's one method, is find the function, which might be a bit of work, and then just plug the number in. But remember, think of these like an assembly line. If I can do f of 3, well, I never found f of x, right? But let's just think about it in order. Let's take the number 3 and apply f to it. That's f of 3. Well, f squares things. So what's f of 3? 9. And we're going to apply f again because we have it again. So what's 9 squared? So that's it, if you have 81. So if you have 1 point, you can just think of applying the function repeatedly, and you don't have to get the whole new equation. All right, so let me stop there.